morning. Oh God, I have an update form. The worst thing that happens when you're leaving the top. Actually got my charger, hopefully power doesn't go all the way to the top. But anyway, yeah. So, good morning everyone. My name is Nikhil Barthwal. I am a tech lead at Google. Come from Seattle, so that's a long way. As well as a flight. A little bit jet lag, but my apologies. So I'm going to talk about Knative. I work on Knative. It's basically in a very abstract form. It's kind of a serverless built on Kubernetes. Okay, so let's actually get started. To start with Kubernetes, that's the de facto platform. It's kind of ironic that you're talking about serverless and you're talking about, oh, I don't want to manage the infrastructure, and then you talk about Kubernetes. It's kind of self-contradictory, But serverless Knative is actually built on Kubernetes. Now, I should mention that you don't really have to know a lot about Kubernetes to use Knative, but it's more for the knowledge that Knative is actually built on Kubernetes, which also means that any major cloud vendor, or if you choose to do it on premise, you can potentially have Knative running on it. And that's kind of good because one of the complaints about serverless is that, hey, it's very, the vendor lock-in happens, but if you use Kubernetes, you don't get locked to vendor. You do get locked to Kubernetes. You have to be locked into something. But because Kubernetes is kind of a standard platform, it's supported by all major cloud vendors. That's usually not a very problematic situation. So Kubernetes as it is basically a platform to build a platform. It's a great point to start, but it's not an end game in itself. And Knative actually is a platform built on top of Kubernetes. And ironically, there are even more platforms built on top of Knative like Riff and so on. So there are a lot of platforms out there. But yeah, Knative is basically built on Kubernetes. It actually extends Kubernetes using custom resource definition. And Kubernetes provides a lot of functionality to us, right? Kubernetes handles like scheduling. It's Kubernetes, essentially, you have like a, description of your infrastructure in Kubernetes can kind of, this is my desired state, or this is my desired state configuration. Kubernetes would ensure that you're as close as possible to the desired state. It handles a lot of stuff for you. For example, it handles scheduling, right? Which container should run, which container should not run. There are lifecycle health checks. The scaling is very important in a serverless, obviously, because you don't want to be doing it yourself. A service discovery, load balancing. You also need data, you need logging, monitoring. So all the underlying basic components Kubernetes is going to do. So what basically Knative is doing is Knative platform built on top. You have all of these things that come with Kubernetes, and then you have other stuff ingredients that you need to build a serverless application. I'm going to talk in details about all of them, but basically it's eventing, right? You want events. It's basically built. You want to have a mechanism how you're going to build your functions or your containers or whatever from your source code to actually the containers that's going to run. You need events to communicate, and then obviously you need servicing, which is basically a kind of, I know Istio does something similar, but it's basically a way of how you route your request. So when we look at Kubernetes, Kubernetes has a big ecosystem, right? There are a lot of Kubernetes actually originated from a Google system called Borg. So Kubernetes, I don't know when it was outsourced, open source, but Borg has been in existence for a very long time. And then one fine day, some people at Google decided that, we want to open source Borg, but Google has a lot of custom infrastructure, so it's not easy to open source. So you basically have to decouple it with Google specific technology. So they did that. And Borg got decoupled from Google specific, and it was renamed Kubernetes, and then they finally open source Kubernetes. But Kubernetes, either by itself or in form of Borg, has been running with Google and with other partners for quite a while. So it's really a battle-hardened, system. But this conference is about serverless. So let's actually look at the state of affairs that we have today. Right? We have been talking about Kubernetes so much. But the point is, developers don't want to do operations, right? Developer wants to focus on their business logic. I don't want to be doing servers, maintenance, and all that stuff. I just want to run my code. I want freedom. I want to use everybody has their own favorite languages, frameworks. So I want the freedom to, build my container the way I want them to be. I don't want to manage the infrastructure. So that's the developer side of the story. Operators have a completely different picture, right? They want something like Kubernetes because they are worried about orchestration. I know I'm from Google, so I'm using a little bit of a Google specific terms, but I mean, that's true for even other cloud vendors. They love something like a managed Kubernetes environment like GKE. And Kubernetes is a fantastic abstraction environment for operators, but not for developers, And DevOps, as they mentioned in the keynote, there's a little bit of a tension between developers and operators, right? And DevOps is a lot about people and strategy and culture, because you have to manage these conflicting goals. Talking about conflicting goals, there's an interesting concept called error budget. And as a developer, right, you want to have new features, so you want to release the code, and so on. You basically want a very short cycle. I want to release a feature. I basically implement it. I test it. I want to release it. Great. The operators, on the other hand, they want the opposite. They want stability. So if you have a high feature velocity, right, the chances that you're going to break something in production is going to be high. So operators basically hate the fact that your service is changing all the time. So there is this conflict between developer and operator. And how do you resolve that conflict? Well, you have this concept of error budget where you say, well, this is the minima and maxima that you can afford to have a downtime. So the developers, they are trying to they have this budget, use it any way you want, you can't exceed it. I can release all the new features as long as I don't exceed my budget. So it's basically for them, it's like a maxima. This is my maximum limit that I can churn. I can have like a downtime. For operators, it's a minima, right? That you have to tolerate this much amount of instability. You must tolerate this much amount of downtime. So error budget is a way to resolve this, conflict between developers and operators. And that conflict in DevOps world is actually a lot. And it even extends to serverless, right? The very idea of serverless, I want to manage my code. I don't want to manage the infrastructure. Yeah, but somebody has to manage the infrastructure. Who does it? Sure, you can have a cloud provider, but in that case, basically your operator is cloud provider, which has its own downside, right? You could get into vendor lock-in and so on. So that's the state of affairs. That's the world where we live in. We have been talking about serverless, right? We have been talking a lot about serverless, but let's actually define what serverless is. And here I want to emphasize a point. I want to differentiate between a concept and an implementation. I think it was Sebastian who mentioned that he took a survey of what first comes to your mind when you talk about serverless. And most of the people said AWS Lambda. And I think that's kind of a wrong answer, because surely AWS Lambda, they are pioneers in serverless, but serverless as a concept is one thing. AWS Lambda is just a particular implementation of that concept. So I want to talk about the concept of serverless. What is basically serverless? Well, serverless is all about, I don't have to manage servers, right? That's where the name serverless comes. Servers do exist. Operators or by cloud providers or whosoever would manage the server. So I don't want to manage the server or the underlying infrastructure. That's one thing. Event-driven, right? I should have these events and I'm communicating with my functions or computation unit or building blocks or whatever you like to call it via these events. So events would trigger. Pay as you go, I would pay for what I use. So if I'm not using anything, I should be paying zero. Although when it comes to implementation, the lines between serverless and microservice, this is really blurry. The fourth one is, as much as possible, I want to be portable. Now, this is not a 100% goal, because you always have to be logged on to something. And sometimes it's not very practical or too much of a problem to be vendor neutral. But as much as possible, you want portability. Now, this is the concept of serverless. Obviously, when it comes to implementation, different concepts, the way they are implemented in a different way. And everything is not 100% the way it should be. For example, talking about pay-as-you-go, I remember when Azure Functions, I used to work for Microsoft before I worked for Google. Azure Functions, you actually have two ways. There's an Azure App Service, I might be mixing up, but there's one way where they call it a serverless, but they have this one container that is always running, right? And their logic is that if you want no cold start problem, you want 100% response, you need to have one instance that is at least running, and then I can scale from 1 to infinity as and when needed. So, I mean, even if you're not using, you're being billed. So that's not strictly pay as you go, but again, the implementation of something can vary from the concept. And that's the point I want to emphasize. These are the characteristics of serverless, right? Implementation would be a whole different story. Okay, so let's talk about Kubernetes, Knative and Kubernetes. What is Knative? So Knative, I've already kind of mentioned, is basically an open source, it's completely open source, Kubernetes-based platform for serverless computing. I have the links towards the end, but if you go to knative.dev, I think that's the website where you have all the information on Knative. On GitHub, it's github.com/knative. And within Knative, you have eventing, serving, and several other repos. So there are these different building blocks. It's a Kubernetes-based, contributions are welcome. And one of the downsides of serverless was that the portability aspect up until recently. Serverless had a lot of vendor lock-in problem. And often people don't like vendor lock-in. So what Knative basically gives you is fine, as long as you can run a Kubernetes or some kind of managed Kubernetes service, I can have a serverless infrastructure. Of course, like I said, you're being logged into Kubernetes, but that's not necessarily a bad thing because Kubernetes is a standard, right? Azure provides its AKS, Amazon has EKS, and Google obviously has GKS. So that's what Knative is. It's pronounced as Knative. That's why I have the right pronunciation towards the end. So let's actually look at the Knative project, what Knative project is. Knative project, I have a set of primitives. I have these primitives I mentioned, build, events, and serving, right? I need a mechanism of how my source code could be built and deployed, so that's build. I need a way to communicate, that's events. And now I need a way to route, that's serving. And it's kind of, it solves like a modern development patterns and it implements learning from Google and partners. Talking about partners, basically Knative now is more like a consortium of industries. The primary partners that we have is Google, Red Hat, IBM, and I'm forgetting somebody else. I don't know, Google, Red Hat, IBM, and Pivotal, yes. So we usually meet every bi-weekly or weekly. There are individual events for like working groups or build events and serving. They meet every week or bi-weekly and then they discuss all the features. But it's basically common ingredients that you need for serverless, and that's the website. Now, when we started Knative used to be a monorepo, right? There was this one, Google loves monorepo. They have the, maybe I'm not exaggerating by saying the world's biggest repo, Google 3 as we call it. But eventually we decided that we want more like building blocks that people can actually combine the way they want, because you might want to use eventing or building for like monolithic services. You may not want to use something like serverless, right? So we provide you these building blocks that you can use them or you can replace them with some other components. And that is why they actually separated this one repo into a set of repos, and they're all under GitHub. I can probably go to these websites towards the end if I should have time. Yeah, I'll go towards the end to the website and I'll show you some stuff. But yeah, so now you can have I can have one version of build running with another version of eventing. So it's not like you have to have like a same version running for all the components. But yeah, that's the Knative project. So what is Knative for operator? Right? Knative for operator, what you have is, well, you have Kubernetes that, as I mentioned, would abstract away all the operational complexity for it. And that's kind of universal. Everybody supports Kubernetes in some form or another. And one of the good things about Kubernetes is through custom resource definition, you can actually extend it. So it's a very extensible platform, and that's the reason why operators love it. Some people also hate it because it's a steep learning curve where, there are trade-offs for everything. Kubernetes in some sense is a beast. It took me a long time to really learn well, and I still cannot claim I'm an expert of it, but sure. But yeah, that's Knative for operators. But what about the developers, the main focus for us? That's Knative for developers, right? So developers want to write code. They don't have to worry about all these build Docker images, uploading to registry, etc., etc. And these components like build, eventing, serving, they would do all of these common codes that they would abstract out. So that's the Knative for developers. And yeah, and these are the industrial partners. I kind of mentioned them. It was initially started with Google, then Pivotal and Red Hat and IBM joined. Now, I know that Red Hat has been acquired by IBM, so that slide is strictly not correct. But when we started, Red Hat and IBM were separate. Now they're together. And SAP also is very much involved with Knative. So these are the launch partners. Riff, I think, is built by Pivotal. I'm not sure what's the relation between OpenWhisk and Knative, but I know Red Hat and or IBM also has some platforms built on Knative, and some of the literature that you read for Knative actually will be the book that I read on O'Reilly. I think it was written by a Red Hat engineer. So yeah, so we have these industrial partners that are very heavily invested, and that's kind of a good thing, because it's a good thing because you're not, it's a battle tested stuff, right? You learn from the way you operate your services at scale, and you incorporate all the learnings and put it in product. And that's why it's a good thing. It comes with a lot of practical experience. So Knative is making a huge impact. So this is the vice president of SAP. He has the following things to say about it. I'm not going to read the entire paragraph, but just the highlight of it. That is to say, Knative further enables SAP to accelerate enterprise-grade serverless event-based application. As you can see from this, there are a lot of technical and business jargons to it, but whatever. So yeah, so that's SAP. IBM Cloud. IBM Cloud also uses, they had OpenWhisk, and then they took a lot of learnings from OpenWhisk. By the way, Knative, I think I have a slide on Stack, but it actually between Knative and Kubernetes, there's Istio also. So I'll talk about Istio. But anyway, so that's the IBM, that's Red Hat, right? They have common building blocks for their hybrid cloud. Actually, to my understanding, the reason why IBM acquired Red Hat was they wanted to extend hybrid cloud technology. And so they are very much into hybrid cloud, and that's actually what Knative kind of gives you, right? You have a way to run the Kubernetes cluster on your on-prem and on the cloud. So you can basically have like a hybrid cloud environment, and you can have hybrid serverless systems. In part, your functions are running on premise, and in part, they're running on cloud, and they're seamlessly communicating with each other. T-Mobile, which is headquartered in my city of Seattle, which is where Knative is mostly developed. So you obviously would expect something there. But yeah, so let's actually look at Knative functionality. And I'll go into a little bit of, I don't have a demo, but I'll go into code and I'll walk through some of the websites. But typically, what would Knative do for you? For one, it's a serverless system, right? And the characteristic of serverless system is it's a pay-as-you-go. So when I'm not using it, I should have 0 pods. So Knative kind of does that for you. That's one thing. It turns developers' app functions into containers. It collects runtime metrics and expose space, because that aspect is coming basically from Kubernetes and Istio, but you have a whole ops side to it, metrics and telemetry, and it automatically handles revision and code config. So now in eventing, it's basically kind of an immutable. So every time you release a new version, you basically create another config, and you can customize in saying, sometimes you need it for A/B testing, that I want 20% of the traffic to go into revision 1, and I want 80% of the traffic to go into revision 2. I'll have an example when I cover the details of it. So I can split the traffic, and I can do like a gradual rollout. So it has all the ways for eventing and configuration, sources and triggers and so on. So let's now move to the Knative stack. How does the Knative stack actually looks like? So that's the Knative stack. Primarily, the 3 primary primitives that we are talking about is build, serving, and events. These are the 3 primary primitives. It runs on Istio, but mind you, these are building blocks, right? So I can swap Istio with another service mesh if I want to, and then obviously you have Kubernetes at the bottom. And then you have several of these so-called platforms that are built on top of Kubernetes, and you can see some of them are IBM, some of them is Google, some of them is SAP, and some of them is Pivotal, which is basically most of the industrial partners that work with Knative. I'll cover a little bit about the service mesh. Istio is a service mesh that allows you to connect, secure, control, and observe the services at scale. It's basically a sidecar kind of thing that you attach. The primary characteristics of Istio is it's an infrastructure layer, right? So it can control, monitor service-to-service traffic, and it's basically a data plane deployed alongside services. They use the term sidecar actually for Istio. So the primary components of Istio, you have an envoy, sidecar proxy, you have a mixer that enforces access control, then you have the pilot, propagation rules, and finally Citadel service-to-service authorization. Anyway, so let's actually move to the primitives for Knative. So serving is the first primitive. The benefits are I can seamlessly scale them per down, which is basically one of the characteristics of serverless. I can have a built-in traffic splitting. I'll have an example on this, but I did mention that you can create different revisions and you can split the traffic. And then I can integrate network and service mesh. And it's very easy to reason about object model. And the way Knative was designed was all of these components, they are like, you can swap them out with your own custom components. So it's a pluggable system. You can connect your own logging or you can have your built-in. Built-in is basically provided by Kubernetes Istio and all the underlying stacks. And there is an autoscaler that you can, plug out if you want to have your own custom code, although I don't really see why you want to, but at least you want. And this is the serving object model, right? So you have service, you have a routing, and then you have configurations. And all of these revisions basically are immutable. They are immutable there's a history built in. So there's a configuration, you have a desired state for your application, you have code and configuration. This separates follows the 12-factor model. Each revision at that point of time snapshot is immutable, and you can route the traffic into different divisions. So you can have fraction in the sense I want 20% to go here, 80% to go here. So here's an example of build configuration, right? So this is an example of the build configuration. There's a lot of YAML in Knative if you were to use it. So there's a revision name, and I can say, well, 90% of my traffic should go to the first revision, 10% of my traffic would go to the second revision. So that's splitting traffic. Now you have eventing, right? You have different event sources, you have event type, flows. The whole idea of serverless is loosely coupled components. So you have event-driven services, and you can declaratively bind them between different producers and services. So it's very scalable, just from few events to live streams, and you can add your own custom pipelines. I have a diagram of eventing. So source to service, that's a simple delivery example, but then you can have channel and you can have a whole lot of complex processing the way you want. These are your principal objects. So you obviously have some kind of producer that will produce the events. You have channels, and then you have subscription. And this Knative is a very active project. I remember an example, I think Christian was giving me, that he built a demo last week and then they rolled out a new version and everything changed. So it's a volatile development area. So it's an alpha product. It has a good thing that, it brings a new feature, but obviously with new features, you have a downside that things change rapidly. Hopefully it goes into production very soon and it stabilizes, then we won't have these problems. So let's go into build. What build is? Well, represents a single job. You also have a cloud build. I'll talk about cloud build later on. Build template, you have a set of orderized and parameterized build steps. And then obviously you need a service account to auth with Docker Hub. So what build basically does is it goes from source code to containers to repository. And you can have build pipelines with multiple steps and, build run in containers. So you don't really need to run Dockers locally. So this is an example. So that's the build templates website. I'll go to the Knative GitHub repository in a short while, but that's an example. They are basically cluster builds. So you can have cluster scope or you can have build templates with namescape scope. So that's an example of build configuration example. API version, it's alpha, as you can see, service account and steps, and you have all of these image, Google Container Repository image, and then you have these commands, and there are a lot of examples on Google Cloud Platform GitHub page on cluster build, right? So it kind of graduates to decoupled continuous integration. You want to use your existing CI/CD, but then you can graduate to audited builds, and there are a lot of benefits to it. So you don't have to cross-compile or Docker locally, cloud caching, etc., etc. I love builds on cluster. So the way Knative today is, it's a one-step deploy. You can deploy with less code safely from source to container using build. You can auto-scale, which is typical characteristic of serverless, and then you can have managed workloads. Fantastic. So I have these websites. I would go into details of one by one. Okay, so let me actually pause here and go dig this deeper. So that's the Knative. So let me stop here. Let's now go. Yeah, so knative.dev. That's the main repository. That's the main website, right? You have a lot of documentation. You have a demos here also. So it talks about Knative. It has all the slide about Kubernetes, Istio, and so on. It explains the various developers, operators at perspective. Lot of documentation. How do you start with each of the primitives, configuration examples? There are a lot of demos. So let's say all samples for serving. So there are a lot of samples for serving for various languages, tools, technology. Go being very popular. Much of it is written in Go. And it's increasingly picking up a lot of momentum for a lot of people, including me, who hate Java. Sorry, I have an opinionated opinion there. But yeah, so it talks about all the logging and metrics. And let's actually move to the GitHub repository. Yeah, so you have Docs. It's kind of the old website. Now it has been replaced by Knative Docs. It's actually a lot of it is. Yeah, so now it takes you to Knative Doc. This was basically the old one, but these are basically the codes. These are the main primitives. Eventing, serving, and you have different event sources, and you have something like build templates also. Yeah, there you go. Let's go into build templates. So you have a whole lot of build templates on how you want to apply to them. Good examples and documentation here, very well documented. And these are the primitives for build. So again, good documentation here. Developing Knative builds. You have eventing. Knative eventing, you have Knative serving. Knative is a very active project, and if you go to something like YouTube, you actually would see a lot of demos. I probably should have a demo, but I just didn't have time to prepare. I apologize. But Knative, yeah, so it talks about Knative, and I think there was a talk by Mark. He's the technical program manager. I think he's a technical program manager who talks. Yeah, Mark Chavani. So he talks about. Yeah, he's in our team. I don't want to put the sound on, but there's a demo. I could have done that demo. Anyway, and Joseph is here. Okay, excellent. So so that's the good place to start. And of course, if you have any questions, you have my contact information. Thank you very much for listening. And I know I'm a little ahead of time, but I'll be happy to take any questions related to Knative or otherwise.
Maybe a question right away. We were discussing the possibility of setting up Knative locally on the developer's machine. Is it possible overall?
Oh, yeah. So you have to set up Kubernetes first. And I think for Kubernetes, you have Minikube. Let me actually go to Minikube. Minikube is kind of a trimmed down version of Kubernetes for. So usually when we do a demo or when we learn, I usually have a Minikube running. So let's actually go to, this is what you need. You need Kubernetes locally via Minikube. So if you want to play around, I would say start with Minikube, then you can have Knative running on top of it locally. That's what you would do. Yeah, we have a question. Okay, I'll get to you, but let me ask. Yes, sir.
Do you know if it sort of works with K3S yet?
Sorry?
K3S is kind of like Kubernetes distribution that sort of the frontier guys have built.
I don't know much about it, sorry. K3S. Let me see if I can find some information on K3S. Lightweight Kubernetes. So this is the great for edge COD. I have like I said, I haven't heard of it. I have tried, but as per the documentation, is a lightweight Kubernetes, so you should be able to run Knative. But I've never tried it. Thank you for letting me know. I'll probably play around with this. The Kubernetes has this problem, and that it's like a beast. It's a very steep learning curve. A lot of people I know, they're using competitive products like Nomad because you get 80% of all the benefits by 20% of the effort. And for some people that makes sense. We don't want to, because your operation cost becomes very high. Not very high, but still, there's an operational complexity with Kubernetes. But yeah, I think you had a question, sorry.
So I played around with Knative a little bit,
Hmm.
and one of the bit of functionality that I kind of really wanted, which I have in all the systems, is the ability to promote builds through specific environments. So maybe we have an environment that like product goes and have a look at before it goes into live. How do I replicate this with on-cluster builds? So because you connect that back to a specific GitHub repository or other Git repository, like how can I replicate that progress through different environments using a in-cluster build?
Why would you have a problem doing that? I mean, what's different within cluster? If you can do it locally, you should be able to do it in cluster.
So typically what I've done is have a specific asset that I build and I move them through environments.
Oh, so you don't have access to those environments and clusters, basically.
No, I have full access to everything. So are you saying that you talk about not using, say, pipelines and things like that and just doing in-cluster builds, but a big benefit of pipelines is that you can move assets through specific environments. So I was wondering how to replicate this kind of, so I deploy it to, say, a dev environment, and then I run a suite of acceptance tests, and then I automatically promote that to the next environment if all those go green. Is there a way for me to replicate that using the Knative building?
On cluster, I haven't tried it, but my guess would be it should be, as long as the environment is accessible, because most of the time it is. I mean, your pipeline isn't existing locally, right? It's somewhere in the cloud anyway. So I think you should be able to. I haven't looked. Let me do this. Let me look into it, and then we can connect back on this, and I'll have a better answer for your question. Okay. Any other question? Yes, sir. I mean, cold start problem would to some extent be there, right? You can't really eliminate it unless you want to go into a model where you have one cluster running always, and then you're paying for the cost, right? I don't. Sorry? In the native way, no, but hey, it's an open source product, so what stops you from tweaking, right? Again, interesting stuff. Pull request. Happy to send us a pull request. Happy to look into it, but I think philosophically it goes a little bit against serverless. So I know that Azure natively provides that functionality to you. Using, I think, Azure has two models for serverless, which is obviously nothing to do with Knative, but they have two models for serverless. And one of them is exactly addressing the problem that I need an always-on functionality. So they'll be like, okay, fine, we'll have one container that is always running, and then we'll scale from 1 to infinity. And the other model is you can go from 0 to infinity, which is obviously going to be cheaper to operate, but then you have the cold start problem. For AWS Lambda, I think cold start, AWS keeps functions alive for a lot of time. So, I mean, cold start problem does exist, but it's kind of mitigated. I am tempted to believe that as technology matures, these problems over the time would go away. Knative would have it, but you should be able to tweak. And you might not have to, I mean, it might be possible to do it via template. You may not have to, change the code for it. Because you can, now actually, you can swap the autoscaler with your custom code. So you don't really have to dig down into Knative, but you have to swap the scheduler, and there you should be able to do that. Yeah, but again, like I said, it's the implications of it is that your one instance is always running, so you're bearing the cost for that one. That's something you have to keep in mind. Yes, sir.
Yes, I have experimented with Knative and Kubernetes. And in Kubernetes, you have your code and you just send it, and it's built in the cluster. Can we do this in Knative? We cannot do this. We have to build our image and then we have to push it to the Docker.
But on cluster build would be able to do that, right?
So you can do this. So,
you
so
can.
in principle, my question is now, you explain now in this build, serving, and eventing. Is this now de facto standard that in principle I can use build from Kubernetes and
yes, you could.
And this are
Yeah.
This
Yeah.
is kind of idea which is very future.
So yes, that was I mentioned that the mono repo thing and then they split it, right? So that was exactly the rationale that we had, that people may want to use their own build component, which is different from what Knative is, right? So during the design of Knative, we deliberately made a decision that we have these building blocks and anything can be swapped. So you could swap the Knative build with your own custom stuff. Nothing stops you, and keep the eventing and serving as it is. You can do that.
I have one question more about workflows.
About?
Workflows.
Okay.
Do you have some standard way how to plan functions?
Stand.
Workflows. If you think about serverless, it's also this workflows as a standard. It's emerging. Can I step functions?
Step functions. I don't think that's something really dependent on Knative, because you're more going into design and architecture aspect of it, right? So what has that got to do with Knative?
No, I'm just asking what should I use together with Knative? Which of these?
I guess it depends on the problem you're trying to solve. I don't know if I can recommend you a particular way because I don't know the problem you're solving. But I mean, the whole idea of Knative is that it gives you a flexibility, which gives you the burden of, I mean, it's a good and a bad thing in the sense you have to make a decision. So I would probably, if I have two different approaches, a very general approach is just to experiment with it and see what works. Knative by definition is quite extendable, so you can twist and turn any way you want it. Did I answer your question? Okay, we can talk in details later on and I can expand on it. Any other questions? Yes, sir.
Thinking about some business logic, it's possible to put in the Knative. For example, in one of the projects we face at the bunch of virtual machines, and if one of them is compromised or we will see some abnormal activity, we want to shut it down immediately and ramp up a new fresh node at the same time. So can Knative do it by applying some business logic? And shut down means we have to notify, we have to throw some kind of abnormal event saying, okay, this is something happened with this pod or virtual machine or with this function, I want to shut it down.
So Knative runs on Kubernetes, and Kubernetes allows you to shut down pods. So simple answer is yes. Obviously, it doesn't provide you a native way of doing it. You have to do all the logic. But shutting down a function in Kubernetes is basically shutting down a pod in shutting down a function in Knative is shutting down a pod in Kubernetes, which you can do. So nothing stops you from doing that. Again, philosophically, you can always, there are ways technically, serverless is a little bit about automation and less about operations. So you're going little against the standard philosophical way of doing it. But yes, you could do that. There's your Kubernetes scheduler can handle all of those problems for you.
But there is no native functionality for that. I mean, no.
There's an API you have to call.
All right.
Kubernetes controller exposes an API for you to shut down a pod. So you have to call that. That's as much native as, they obviously cannot make a decision, I want to shut down this pod, right? That's a decision you have to make. But once you make that decision and you let it know through the API, Kubernetes would do that for you. Yeah. Any other question? No? Yes.
One more. We have here to run all the time Kubernetes cluster. And in this AWS, you just focus on AWS Lambda, you just focus on the function. So how to explain the bigger cost of, it's not really idle on the end, because you have to run all the time cluster.
Well, so
What is it?
the thing is that if you're using a managed service, then that managed service is not you're paying for obviously your containers, but that managed service is not something that you're paying for, right? So you're scheduling that is done by that managed service. You don't have to worry about that cost. You don't have to worry about the cost of managing the service because that's done by you, by GKE or whatever, AKS would do that. So I don't think it disrupts your pay-as-you-go model. You only pay for the actual functions that you're using, right? Not the part that overhead that you're talking about, that something is orchestrating and that is always running. Do I have to worry about that? No, you don't. Unless if I'm getting your question correctly. Yeah, okay.
Is there much overlap between what you're doing in Knative and what Google are doing in Cloudrun?
No, there's actually built on top. So Knative is Cloudrun is basically a managed version of Knative. Now, what you have is, let's say I have basically GKE, and then I'm going to set up all these primitives and everything. Cloudrun says, we already have it for you. So Cloudrun basically uses Knative. It's built on top of Knative. So it's basically a superset. And I can't talk too much, but today is Google Next, and there are some exciting product announcements that are going to happen. Unfortunately, by San Francisco time, it's going to happen late today. But a lot of other managed services related to Knative are going to be announced today, which I can talk tomorrow, but not today because I don't want to announce before the official announcement. But yeah, it's actually very unfortunate, right? See, if we were in a time zone that was away from the San Francisco, I could have announced because by now it would have been announced in San Francisco. Then I'm not worried about telling other people.
You can tell us, we won't Twitter it.
Yeah, but see, there's a video right there. Then if you shut off the video, maybe I
It's
can.
not live, so it's published later on.
Yeah, but they have a timestamp on it, right? So that's still a problem for me. But I can, if you're willing to wait till tomorrow, I can tell you tomorrow. Then there's no problem. And then I'm safe also. You can even tweet it after that, I don't mind. Next question. Yes, sir.
So where's the Knative project going? So there's some building blocks. What are the next steps?
That's actually the product announcements that's going to happen, right? so I can tell you very vaguely. Okay, I don't want to go into specifics, but you obviously have a framework, right? And a natural evolution of framework is some kind of managed service that supports, because I don't want to set up framework, right? I want to automate it as it is. Then I also want some kind of mechanism saying, hey, hybrid cloud is a very big priority for a lot of cloud vendors, including Google, because enterprise wants hybrid cloud, right? So I go into an evolution where I'm running some instance locally and some instance on the cloud. How do I communicate, right? So the products, basically the managed products or all those that are going to be built on top of Knative would handle all of these issues for you.
So what I saw from the Knative intro so far is that it involves yet another lots of YAML editing?
Yeah, I
Is there
mean,
like going to be
um,
different language support or some other way to
I think,
handle all this?
yeah, there's a startup that is working on this. Pulumi, is it, or something? I don't know much about them, but they are actually addressing this problem that, hey, everybody, like, there's a lot of copious amounts of YAML, and you know, developers want their favorite, whatever, Java, C++, whatever you want, to do all these configuration files. But if a very simple solution that I have is, if you have YAML, you can always write in your own language and some translate it into YAML, right? That's an additional build step that you can do. What stops you from doing that? Your build becomes two-step, right? The first step of that build is to generate the configuration file, and then second step is to use that configuration file to move to the next step. So that's like a workaround that you could do.
Yeah, but obviously Knative already has its own model, right? So
Yeah.
why not expose that to different languages?
I mean, it's potentially, it can be done, but it's a very, again, my personal take on it is that it's hard to do it because there's a wide variety of things, right? I mean, okay, I can replace YAML with something, but what is that something? And if I take, like, what do you want? Somebody may say I want A, other person may say I want B, and somebody may say, and very soon I have, like, 50 different ways in which I can express that configuration. Which one do you choose? So such kind of nitty-gritty customizations often are hard to implement, more because everybody has a different way of doing it. So it'll be like, okay, we'll give you one standard way, because if you have too many ways of doing the same thing, you confuse the other person. So we'll give you one standard way, but hey, we give you the ability to extend it whichever way you want. We're not stopping you from doing that. And again, it's open source. Do whatever you want. I mean, if you don't like YAML, play with the code and change it. Who stops you? Yes, sir.
Is there any kind of desire for this within the project to sort of make it harder to CNCF?
Sorry. Eventually, it would be given to CNCF, but right now we haven't made any firm decision on that yet. My suspicion is that that's where it would head to. Google is very much involved with CNCF. Kubernetes is basically, CNCF, and they sponsor a lot of events, including, I think, next month, is it the Barcelona CNCF conference, KubeCon, right? Which they are the, I don't know, gold, silver, something sponsors. Yeah, they had one in December in Seattle. I didn't attend that, but several of my team members, they gave a talk on that. So yeah, I would expect it to go to CNCF at some point in time in future. More questions? No? Well, in that case, thank you very much. I was afraid that I finished up in time, but you guys asked me so many questions that I actually covered up all the time. So I like that. Yeah, and I appreciate that. I wanted to let you know. Thank you very much.